Alright, 3.2, theorems about perpendicular lines. All right angles are congruent. This is our first theorem, theorem 3.1. And so, for instance, our two little pictures we have here, I could summarize this and say, if the measure of angle 1 is equal to 90 degrees, and the measure of angle B is equal to 90 degrees, then angle A is congruent to angle B. All right angles are congruent. Because both these are 90 degrees, they're going to be congruent to each other. Right, that little square symbol means 90 degrees. And since both of these are 90 degrees, we can say that they're the same measure. All right, theorem 3.1 continued. If two lines are perpendicular, then they intersect to form 4 right angles. So if two lines intersect and they're perpendicular, means they meet at 90-degree angle. That means all 4 of these angles must be 90 degrees. So we say if N is perpendicular to M, and if line N is perpendicular to line M, then the measure of angle 1 is equal to 90 degrees. The measure of angle 2 is 90 degrees. The measure of angle 3 is 90 degrees. And the measure of angle 4 is 90 degrees. Alright, so now we're going to practice these two theorems, applying these two theorems. And let's go through why. In this diagram, R is perpendicular to S. So here is line R, here's line S, and they are perpendicular. If you have two lines that are perpendicular, they intersect to form 4 right angles. We also see that R is perpendicular to T. So R and T, they intersect to form 4 right angles. So you draw out, all 4 of these angles are congruent. They are all 90 degrees, they're all right angles. And now, that's all we're given. Alright, we were given that 3 was 90 degrees and 5 was 90 degrees at their right angles. Alright, let's see. Angle 3 and angle 5. Yes, we have enough information to say that this is true. We can say, yes, they're both 90 degrees. Right, 4 and 5, angle 4 and 5. Well, angle 4 and 5 are both, yes, once again, they're both 90 degrees. They're both right angles, which means they are 90 degrees. Angles 2 and 3. 2 and 3. Well, we know 3 is 90 degrees, but we don't have enough information to talk about 2. Right? We don't know. Is it perpendicular? Is this a 90 degree? We were not told, so we cannot assume. Right, in the diagram, G is perpendicular to E. So E, G, those are perpendicular, which means they intersect to form 4 right angles. G is perpendicular to F, so it's these two lines. So that means they intersect to form 4 right angles. Let's see if we have enough information. 6 and 10. 6 and 10, they're both right angles. Right? We can say yes, because all right angles are congruent. Seven and 10. 7 is also 90-degree angle. So we say yes. You could talk about how 7 and 6 are vertical angles. They're across from each other. They're both 90 degrees. And then because 6 was congruent to 7 and 6 is congruent to 10, 7 and 10 are congruent to each other. Six and 8. 8's over here. We don't know if it's 90 degrees, so we don't have enough information. 7 and 11. Well, yes, because once again, they're both right angles. Right? So we could say 11 is a vertical angle of 10. 7 is a vertical angle of 6. Because 10 and 6 are congruent, 7 and 11 will be congruent as well. Alright, 7 and 9. Oof, 9 is over here. Once again, not enough information. And then 6 and 11, and the answer is yes. For all the same reasons we've listed before, all right angles are congruent. We could talk about vertical angles and right angles being congruent. Alright, if two lines intersect to form adjacent congruent angles, then the lines are perpendicular. So I could say if angle 1 is congruent to angle 2, then line AC is perpendicular to line BC. So I have two angles that are formed by intersecting lines, and those two angles are next to each other. They're adjacent and they're congruent. The only way this could happen is if the two lines are perpendicular. Because imagine if I had my two lines like this, right? You can see these two lines are not, these two angles are not congruent. The only way for those angles to be congruent is if I drew my angles this way. Okay, so the only way these two angles could be congruent is if we meet at a 90-degree angle, if they are perpendicular. Alright, and if two sides of adjacent acute angles are perpendicular, then their angles are complementary. Alright, this means add up to 90 degrees. So, I could write this out as, let's see, if ray EH is perpendicular to ray EH, then the measure of angle 3 plus the measure of angle 4 is going to be 90. So what this says is if this first ray and the second ray are perpendicular, so meet at a 90-degree angle, that means if I add my two angles up, the total should be 90 degrees. In the diagram, EF and EH are perpendicular, so these two meet at a 90-degree angle, which means my two angles, when I add them up, should equal 90. Solve for y. We get y is equal to 10. Perfect. Find the value of each variable. Okay, so here we have EFG. EFG, so EFG is this guy, is congruent to HFG. HFG is this angle. So if they're congruent, that means this must be 5x as well. The only way for two intersecting lines to form adjacent congruent angles is if they are perpendicular. So that means these must be perpendicular. They must meet at a 90-degree angle. So I can set 5x equal to 90, divide by 5 on both sides, and I get x is equal to 18. You also could say, well, the total, let me write this out, equals 18. You could also say, well, the total is going to be, 5x plus 5x to go all the way across, and that's 180. So we have 10x is equal to 180, divide by 10. Once again, you get 18. So either way would work. Alright, AB is perpendicular to AD. So these two are perpendicular to each other, which means if I add the angles, this is 9y, this is 36. If I add the angles, the total has to be 90. So y is equal to 6. Alright, solving inequalities. There's two ways you can do it. You could multiply by the reciprocal on both sides. Multiply. We get x is less than, so let's see, negative 2, so negative 3. Or if you need to do it slower, that's fine. 2/3 x less than negative 2, so multiply by 3 on both sides. 2x is less than negative 6. Divide by 2, and we get x is less than negative 3. Now, the reason we did not switch the direction of the inequality is because we are multiplying and dividing by positive numbers. Alright, so I have negative 3, open circle, and the arrow goes to left. Alright, there should be parentheses here. So we have negative 3x plus 15 is greater than equal to x minus 1. Let's go ahead and let's add 3x on both sides. Add 1 on both sides. Divide by 2. 8 is greater than equal to x. So if 8 is greater than equal to x, it means x is less than equal to 8. So I like to write my variable on the left side. So I have my closed circle. That way my arrow goes the correct way. Because if 8 is greater than x, it means x has to be less than 8. Alright. Let's see. Let us subtract 1/3, so we have negative x. That's greater than or equal to, let's see, 2 minus 1/3 is the same thing as, okay, let's make a common denominator. So 6/3 minus 1/3 is 5/3. But wait, I have a negative x. If I multiply by -1 on both sides, I have to flip the arrow. So 5/3 is -1 and 2/3. So -1 and about 2/3 is about here. So I have a closed circle, and then my arrow goes to the left side. And last one. Let's subtract x, subtract x. So I have -1/2 x plus 4 is less than or equal to 0. Subtract 4 on both sides. Multiply by -2. Well, okay, I can multiply by -1 first. So I have 1/2 x is greater than 4 because I flipped the direction of the inequality. And then if I multiply by 2 on both sides, I get x is greater than 8. So open circle, and the direction goes to the right. So we had to flip because I multiplied by a negative number. Right, so right here, multiplied by a negative, so therefore I had to flip my inequality.